Hey everyone, welcome. I'm just watching the participants window start populating. So as soon as we see things even out, we'll get going, usually about 2 or 3 after the hour. But hey, welcome everyone. Thanks so much for spending your afternoon with us. We'll get started here momentarily. Hey, welcome everyone. We're just waiting for everyone to settle in and get loaded up. Um, Still seeing some people coming into the participants window, so fantastic. As soon as I see that evening out a bit, we'll go and get started, probably here in a couple more minutes. Thanks. All right. Okay, so I think we are now looking at 103, so we're going to go and get started. Thanks so much for hanging out with us this afternoon. So my name is Charlie Day. I am the training lead for DesignSafe, and we bring you these monthly webinars based on different topics, some of the topics that you all have asked for. What I asked for, there's going to be a QR code coming up here shortly. If you can scan that QR code or get ready to scan that QR code, we would really appreciate it. We'd love to hear your feedback. We'd love to know what you thought about today's presentation, previous presentations, and give us some input on what future presentations you'd like to see or future topics you'd like us to cover. And we will definitely take all that under consideration. So thanks so much for joining us. It is a chilly but sunny afternoon here in Austin, Texas. So we're great you can join us today. Hopefully the weather is pretty decent where you all are at, but hey, it is the middle of December. But it is also the middle of December, so classes are ending and semester is coming to a close. So thanks so much for joining us today. So today, if you notice, there's a new story on DesignSafe as well, that we're doing some improved predictions for modeling earthquake damage. So if you're interested in that story, please check it out. I'd also like to point out that that was one of our winners of the 2024 DesignSafe Data Awards. Please check out DesignSafe and check out that story. Whoops. Wrong window. All right, so there's the QR code I was talking about. So if you can, go ahead and scan that. We'll, again, display this at the end of the presentation as well. And then we will tell you all about how you can get to the recordings of our webinars and past webinars. All right, so today's webinar is about resilience assessment. So if you notice, resilience modeling has kind of taken a upward tick over the last decade or so. And what we have today is talking about how to do this resilience modeling using DesignSafe and what tools on DesignSafe can support you with that. With us today, we have Dr. Jamie Paget, who is department chair and professor at the Civil and Environmental Engineering Group at Rice University. She's also one of the co-PIs on DesignSafe, and so she has a wealth of knowledge behind her. And of course, a very well awarded professor as well. And with her is one of her students, Raul Rincon. So Raul's a PhD candidate, just about to finish up his PhD with the Civil and Environmental Engineering Department at Rice University as well. And the both of them will be presenting how to do this resilience assessment using DesignSafe. So once again, if you have any questions for our presenters, open up the Q&A dialog box, type your questions there, and then we will cover those questions at the end of today's presentation. All right, with that, let me go ahead and hand it off to Jamie and Raul. Thanks so much for joining us this evening. Looking forward to the presentation.
Awesome. Thank you so much, Charlie. Hello, everyone. Just want to echo Charlie's welcome to you all. Missed the chance to see your faces or see your voices, but I see a lot of familiar names on our attendee list and some new ones that I hope to get to know better. So thanks for joining us. It's a sign that we have some common interest in this broader field of risk and resilience modeling. So we'll start with some highlights today about how some of the DesignSafe Cyberinfrastructure resources can hopefully enable some of your work and the much needed advances, I think, that are still out there in our broader field. Let me share my screen. So our mode of operation today, I am going to give you a little bit of background on some of the ties that I see for our community to the resources that DesignSafe provides, and particularly one link and how it enables connections to Encore. And I'll tell you a little bit more about Encore today. And Raul is going to follow that up with some more demonstration of really the behind the scenes and how we can leverage Jupyter Hub and some of the DesignSafe resources for enabling computation in this space. So hopefully a bit of a practical example that we can share with you and that maybe you could build off of in the future. So let me share my screen. And if you guys could confirm with me, maybe Raul, if we're seeing the right version. Okay. Wonderful. So we'll get started taking a look specifically how we can leverage some of the high performance computing resources at DesignSafe to support work in this broader infrastructure resilience domain. But also we'll talk about some of the other opportunities for leveraging the CI and some of its, particularly its interoperability with Encore as a platform that supports community resilience modeling. So for those of you on the webinar today, perhaps one thing that attracted you is you're working in this broader domain of community risk and resilience modeling or infrastructure recovery modeling. And really this resilience problem is one that we see as laden with multiple sources of uncertainty and also a lot of complex interactions that cut across scales. And in fact, those are some of the reasons that we see the resilience problem as being ripe for support from and resources from the cyber infrastructure. We often follow this type of chain series of analyses that include characterizing the stressor or the hazard, simulating its spatial distribution and impact across a system of physical models. This exposure modeling is coupled with predictions of damage potential, often leveraging fragility functions, and are used to look at the likelihood of damage to not only individual components, but also systems of infrastructure and look at cascading consequences. And we may look at these in terms of a number of different consequences, whether they be with respect to functionality or economic implications or serviceability. Resilience pushes us to move beyond that T0 immediate impact of hazards and look at recovery models and recovery trajectories over time. Here's where we often start to consider challenges that move beyond the built environment and the physical assets alone and look at the intersection of the built environment with, say, economic resources or availability of crews or human decision-making on interventions. And then this recovery over time is often characterized with a range of different types of performance metrics. You see a really generic y-axis on the plot here that indicates some measure of community functionality. This may imply that we have broader coupling with social systems modeling, things like population dislocation or economic implications across the community, or it could be a measure of service of infrastructure systems through time. And in some cases, we start to try to collapse this temporal evolution into metrics of resilience for ease of communication. But of course, all of these challenges require us to couple a series of models or analyses, perhaps that have been disaggregated based on domain expertise. But we often are pushing ourselves to identify, quantify, and propagate sources of uncertainty through this analysis. Therein lies additional computational challenges in terms of some of that, at least, for example, forward uncertainty propagation. So these problems are laden with uncertainty. They're multi-scale, they're dynamic, and we may have systems interacting across the sequence. And they may support multi-criteria decision-making. There may be a number of different metrics that we're aiming to quantify to support things like, say, optimal recovery. And I think that those challenges are some of the same that we'll come back to at the end, where I would say that cyber infrastructure like DesignSafe are prime for supporting some of these problems. I wanted to get us all on the same page in terms of just some terminology and perhaps different ways that we're all approaching this problem, both in terms of our denotation, but also in terms of the type of problems or the type of questions that might be supported by these analyses. So for example, we may be looking at scenario-based analyses or conditional risk models. This might imply, for example, that we're considering a scenario earthquake or a scenario hurricane event, coupling that hazard analyses with uncertain damage predictions across a potential portfolio of infrastructure systems, and even looking at consequences of that damage, for example, such as losses. And those are the examples that are shown here, different types of conditional risk estimates, either scenario-based failure probabilities of assets across a portfolio, or losses not only at the individual structure scale, but that may be aggregated across an entire portfolio. And these types of analyses are particularly poised to help us look at things like emergency preparedness, where a lot of, say, emergency management agencies may have these desktop exercises and look at different what-if scenarios, for situational awareness as an event occurs or is unfolding, or even in some recovery planning exercises. Perhaps more appropriate for supporting things like risk transfer or financial protection, identifying and investing in risk mitigation solutions, or policy decisions would be our unconditional risk models. This implies that we're also propagating that whole suite of potential hazard intensity and frequencies so that we can assess things like an unconditional failure probability or evaluate things like expected annual losses across a whole portfolio of assets. In terms of the examples that we'll be looking at today, that first scenario-based risk assessment is the one that we're going to focus on in our examples, but also look not only at T0, the immediate aftermath of the event, but look at recovery trajectories as they evolve in time. And of course, this is what some of the implication of that resilience language is implying, that we're looking at how a system performance evolves. This is just one example of a metric that could be considered, for example, for a networked infrastructure like a transportation network that Raul will show you, looking at an efficiency-based measure of functionality. And then lastly, as we talked about at the very beginning, we might look at different resilience indices or resilience metrics that essentially look at some cumulative or integral of that recovery trajectory normalized over time by a pre-event recovery. And this is particularly effective in supporting decisions like resource allocation planning or targeting infrastructure improvements that look at expected functionality over time, not only post-event direct losses. And as Charlie implied at the beginning when introducing this webinar, I would say this field certainly has taken off over the last decade or two. And now we see researchers across the globe that are either tackling different pieces of this resilience modeling problem or supporting whole workflows in terms of these coupled models across the resilience modeling trajectory. Just a few highlighted here, but not all encompassing. And the ones that we'll be focusing on today, I mentioned DesignSafe as really some of the enabling cyber infrastructure that I want to talk about, how I hope it can support some of your workflows. And we'll be highlighting an example of coupling a Jupyter notebook or the JupyterLab through DesignSafe with NCORE, which is the product of our NIST Center for Community Resilience Planning that has been working towards this problem for almost the last 9 years or so, with a recent emphasis on developing an open source community resilience modeling platform, NCORE. Certainly no one center, even center scale effort, and no one platform likely to have all of the pieces that you might want at your disposal for resilience analysis. So today we're going to emphasize how you could leverage DesignSafe, couple some of your own models or data, pull from other resources like NCORE, and then conduct your analyses along with data sharing, integration, and publication. So I mentioned that NCORE is one of the products of the NIST-funded Center for Risk-Based Community Resilience Planning. And the idea is that this modeling environment is transitioning to being one that's open source. So hopefully we'll see contributions from this community to this open source platform in terms of either hazard models, tools for fragility and damage analysis, looking at recovery modeling, overlaying systems integration with social or economic systems. What we're going to highlight today is how we could perhaps interact with, talk with NCORE to pull some of the models to support a broader workflow for resilience modeling. And so that implies that NCORE is not necessarily your only tool of choice for community resilience modeling, but hopefully one that this community can leverage for resilience modeling, computation, and even broader resilience planning and recovery efforts. But I think the vision of the interoperability with DesignSafe implies that you might even be able to couple and leverage some of the tools from the other efforts in this space within your analyses. So that may be a topic for a future webinar, is integrating and leveraging tools from some of these other platforms, including things like another NERI funded resource, the SEM Center, who's working broadly in this space. In terms of some of the NCORE environment, today you'll see a little bit about the Python package that enables local analysis and enables interaction with the NCORE web services, which is hosted at NCSA at the University of Illinois. The NCORE web services that allow users to create and access fragilities, hazards, data that's already pre-populated for specific test beds. And we'll be interacting with that through, of course, one of the DesignSafe resources, our DesignSafe Cyberinfrastructure, which hopefully you're familiar with if you joined us today on the DesignSafe webinar. But I do want to talk briefly before passing it to Raul about how some of the DesignSafe resources may more broadly support your work in this community resilience modeling space. Certainly you may want to check out some of the components like the data depot, where you may find things that are either already published or that you may use in your private workspace. Check out the tools and applications, including simulation and data analytics tools, and we'll come back to that in a moment. The Recon portal, particularly apt for those who might be looking for validation data for their community resilience models, or even empirical data to build some of the pieces of a resilience modeling pipeline, like empirical fragilities or recovery functions. And then you'll find a lot more material with respect to some of the user guides and use cases, including some in this space related to visualization of spatially distributed systems, or a use case tied to this in-core interoperability. And today, you're seeing some of the training and user support, but I do want to mention the others that are out there, some that you'll find directly online, and also some of the opportunities, for example, for using some of the office hours through DesignSafe with Maria Esteva. One quick mention in the data depot, a lot of times I get questions about having your data be in there and be publicly available before you're ready. Just want to note, in our field, we do a lot of collaborative work. And so one thing I'd want to encourage is that you consider setting up a project for especially these types of collaborative resilience projects. It will remain private just with your team until you decide to make it public. And at that point, you can receive a DOI. It'll be citable. Others can reference your work and your data or your models. So you'll keep it private in your projects until you choose to make it public and published. And you may want to check out some examples if you haven't already explored DesignSafe. But one thing I highly want to encourage, start citing data sets. In our community, this is a real important shift. And those citable data sets might include things like pieces of the resilience modeling pipeline, whether it's inventories of infrastructure data. I'll show you some examples, whether it's the models that were used to derive fragility functions and associated codes and scripts, or validation data from reconnaissance missions. And you'll see if you start to look through them that they should have a nice data structure that's easily communicated with some README documentations and some metadata assigned to it. Please do help us to make the shift that not only do we view field data and experimental data as shareable, publishable data, but this work in the community resilience field, which is highly computational, model or data driven, is also really appropriate for sharing in a formally published data set. And then start citing not only your own DOI, but as you're reusing others, be sure you're citing those in your reference list. And this is just a quick high-level example, but if you start to take a look at the DesignSafe Data Depot, you'll find a lot of projects already published that tie specifically to resilience modeling, but even more specifically to in-core related data sets. So for example, some of our center test beds like Seaside have all of the infrastructure, population, and hazard data published on DesignSafe. Tools for field data collection from past studies like the longitudinal study in Lumberton, North Carolina. Other example, inventory data sets like the electric power network from Galveston. We're generating V2 right now to share, or other social science oriented data and codes like an automated neighborhood characteristics example from Nathaniel Rosenheim. So just a few of many examples. On the tools and apps, if you go to simulation, you'll see a lot of those that may be good for behind the scenes model derivations, for example, for simulating hazards or for generating fragility functions. The one we're going to focus on today is looking at leveraging Jupyter specifically to launch some of these styles of chained resilience analyses, and specifically how we can leverage some of the high performance computing resources through Jupyter. Won't dwell too much on the Jupyter Hub or Jupyter Notebooks here because you'll see direct examples with Raul, but we'll look at using the JupyterLab, how to interact with and launch simulations that speak to NCore and pull data and models from NCore, and then how you can launch HPC jobs, and that can essentially allow you to leverage some of the high performance computing resources at TAC behind the scenes at DesignSafe. So again, why DesignSafe, I think, is particularly a good resource for our broader risk and resilience engineering work. We often work in multidisciplinary teams. So some of the collaboration tools and just ability for shared resources through DesignSafe, I think, facilitate that interaction. We have complex and computationally expensive models and simulations, even within an individual module of a broader resilience workflow. And so that access to free high-performance computing resources is particularly necessary for a lot of this work. And we do require data. We require data for model building, testing, and validation. And we can avoid reinventing the wheel for certain pieces of that resilience modeling workflow if that's not your particular emphasis of your work, but you want to see how your work influences an overarching resilience metric, for example. So sharing and reusing data from past events, particularly relevant for our field, advancing this notion of shared models as publishable data. And then when we're looking at either real or synthetic test beds, I think this is a really beneficial, valuable way that we can leverage DesignSafe, is to use that as a platform to share them. So you can test out your own new models and scripts on them. I will say that our community is still underrepresented as both users and contributors if we look at some of the resource allocation of DesignSafe or the publications. And so I hope that those on this webinar can help to change that. So certainly consider how you might contribute and share and publish and have citable DOIs for your work, as well as leverage some of those interoperability features or HPC resources of DesignSafe. So with that, I'm going to pass to Raul, who will walk you through leveraging that specifically with a physical example and JupyterLab on DesignSafe. So I'll stop sharing and pass to you, Raul.
Thank you, Dr. Paget, and welcome everyone to this second part of this session. Let me share on my screen and confirm. Okay, I'm gonna be very brief in this presentation. I just want to explain what we're gonna do with the Jupyter Notebook. And let me say something first, because this is being recorded, what we want is for you to have this available in the future. So we're gonna publish the Jupyter Notebook and the tools that we're sharing today. And also you can use this video in the future to navigate. If you have some questions, also you can send us emails. But it may be very quick, as you know, we have only 1 hour for the whole webinar. So what we're gonna do is we're gonna show this interoperability by leveraging physical models from data that has been published in Data Depot. So we want you to show you how you can take data that is already available. In this case, it's a transportation network in Memphis. We have a network, a network of roads and bridges with information of the system parameters that we could leverage to describe their fragilities. For fragilities, we're gonna use pre-published data in NCore, as well as the mapping functions that will that will link the information of the fragility functions for each system and the systems that are exposed to a hazard. And for analysis, we're gonna then retrieve the probability of reaching different damage states for a specific scenario. And then to continue this interoperability, we're gonna leverage some scripts that we have coded specifically in this Jupyter Notebook to share, that for each of the simulation of the in this case of the damage state, will compute or estimate time to recover functionality of each bridge, then schedule the recovery process. And with that, we can estimate the network states, how occurs the evolution of the functionality, starting from some links that lost functionality. Then in yellow, I'm showing here examples of how they recover or they're being repaired until you reach the total functionality. So one of the metrics, for example, in this global analysis, because we are checking it here at the network scale, the functionality, could be the normalized global efficiency. We published recently a paper in which we show an example of this. And what we do here is normalize the global efficiency at time t divided by the original network efficiency before the damage or the event occurs. What is the network efficiency? It communicates how easy the different nodes can communicate to other nodes in the system. So with that, we're trying to underscore the importance of trying to reach any node, for example, for reaching people that have been lost their functionality at some point after the event. Now, computing the network efficiency means that you have to estimate the paths from one node to all of the rest of the nodes and then jump to the next node and do that iteratively, which means that in this example, if you have 500 edges, you will have to estimate around 250,000 number of paths, which becomes expensive. And that is for one single simulation for one specific damage scenario. So imagine doing this multiple times. This is what we're gonna leverage HPC in the Jupyter Notebook. So you see the three, again, to summarize the three things. One is leveraging data already published. The second one, PyIncor. And the third one is the HPC. So those three through DesignSafe. When you are in DesignSafe, the data depot will show you the published already data. And today we're gonna focus on one specific. Let me show you the polished data here. Today, we're going to focus on one specific project that we published 1 year ago. That is this project 3939. I'm going to very quickly navigate with you what you will see here. It's a Jupyter notebook with different strategies to visualize risk and resilience. We also are going to show some of these examples in today. But something important here is the shapefiles. We're going to take the shapefiles of the bridges and the shapefile of the network. That information is going to be leveraged and how we can access. You can see here the route. For example, let me click on this. And if you check the metadata, you see here, this is on the PRJ 3939P3. It means that this is the version. So you can change the version. Once you have published, you can also make amendments and publish or change some things so you'll have new versions or not. And we're going to leverage this data. You can see here, the version is version 3. So how we can access this, we're going to do that through tools and applications, and we're going to go to Jupyter Notebook. As Dr. Payet mentioned already, you have different possibilities. One of them is the regular session in which you're going to have, let's say, a development way of seeing Jupyter. If you want to leverage the power of DesignSafe, you will get to use either HPC CPU or HPC GPU. Today, we're going to use CPU. When you want to leverage parallel, then you have to wait where there may be a queue list. So I already did this and submitted, and we have a node that is being connected. So when you connect, you're going to see a different thing. You're going to find this. Once it is ready, you connect to a node, and you're going to see this. You're going to see your Jupyter lab with only 2 folders, my data and work. And you will see here the link that starts with Stampede 3. When you connect to the regular session, you're going to see Jupyter DesignSafe-CI. And you're going to see more folders. So that's one of the differences. And I'm going to check later on that. So let's start with today's work. We go to my data. In this case, I will publish this. Then you will find it in the published projects. I have this webinar. And I have only here DesignSafe Jupyter Notebook and exposure. There is nothing here. So what we have in our Jupyter Notebook, this is the one that I mentioned is going to be published. You're going to see here a different set of possible libraries that you have to install. Those are pre-installed if you open your regular session, but because we're using today PyIncor, you're going to need to install PyIncor in this session or in a new Conda environment. For that, you're gonna find here a link that sends you to an Incor user guide that we already developed. After you have all of that installed, because today we're not gonna show that, you have to import the libraries. The libraries, most of them, again, are pre-installed. And usually I like getting the route in which you can see where you are working on. So we are in the current directory is going to be home, Jupyter, and my data. So this is the link or the route where we are working on. And I'm gonna show you later why we need it. So first thing, reusing the data. I show you that the path started by PRJ3939v3 shapefiles. But before you have to add this, you can find them directly. So it means that I can navigate from my JupyterLab to any published data here. So if I open this, I'm going to see all of the projects and I can access to any one of them, right? So this is one thing that we want you to leverage because you don't have to go and repopulate every time you do something once it is published. So if it is published, let me bring the two. Let me go back. Okay. The two shape files that I mentioned, the bridges and the road network, so I can pull them with GeoPandas. I loaded GeoPandas as GPD, and once I pull this data, I can visualize it by adding a figure and, for example, a background, and we can see here what is the data that we are going to work today with. Again, if we see, we don't have anything in our project right now. We only have our Jupyter notebook. If we want to save that in our folder exposure, we can do the following. We can run to file, and that is going to save it directly here. Shows a message, but what it is doing is saving the file because there are many different columns in that shapefile that I don't need. So I did something first. I did a filter. So I just pre-selected the columns that I needed, and I added a new column called class. For this example, I'm using a single system or class to relate the bridges in this shapefile with the fragility functions in Incor that is called MSSS concrete, right? But you could do something more specifically so you can get different structural classes for each of the bridges in your dataset. Once you have this, another thing that we need to add beyond this system is the globally unique identifier, the GID, to all of the exposed assets. You can do that using PyIncor function that is called GeoUtil. And once you use that, you can now have a globally unique identifier. Let me check something very quickly. For example, we can see here. Oh, okay, let me copy this so we can see what is doing this. If we see the new geodata frame that is called bridges, we don't have a globally unique identifier. So when PyIncor is using this shapefile, won't be able to tie it with the damage analysis that we're going to use in the future. After doing that, we can check later. We're going to have these globally unique identifiers so we can relate with each specific asset. Now, to create the dataset in PyIncor, we need to submit the files that we just created. So I just put the names on a list, and we're going to send that to NCSA and have an exposure model. First, we have to connect with the Incor client. You're going to be asked to give your user and your password here. I already did it. And then now we can access to the different web services that already mentioned Dr. Payet. For example, the data service with the client that we just created help us to create a data set for the bridges. Every time you create a model or a service in PyIncor, it will give you an ID. With this ID is trying to link your model that is going to be saved in your user in Incor, so you can rerun different type of analysis just now calling this ID. Once you create this ID, you add the files that we created, these 4 files, using the list that is called imported files. It's here, imported files. So we do that, and we are sending now the files to NCSA, and the model is being created there. What we're missing after creating the exposure dataset is the mapping function that again connects the fragilities with the exposure dataset. This mapping ID, I found it in Incor, for example. Once you create an user, you can go to Web Tools, DF3 Viewer, and mappings. For example, I wanted to use this default, let me check, fragility or earthquake or bridges. For example, I want to leverage this default bridge fragility mapping, and you have here an ID. You copy this ID, and it's the one that I'm going to pull. So this is one of the things that we want to leverage here. If there is a community creating specific fragility functions for different systems, it would be it won't be necessary for you to create those fragility functions if you can leverage them. So in this case, there are a set of rules. I won't go through the process. You can find the information specifically in this web page. But what it does is maps a class column, the name it has in the class must be, for example, MSC concrete or MSC steel, etc. We selected just one, right? So we go back here and we create this. Oops, I did something incorrectly. Okay, let's continue. Once you create that mapping, you then create the hazard. Hazards can be leveraged directly from different libraries or functions within DesignSafe tools, or can be also with PyIncor. In this case, I'm creating different hazard scenarios. This function is going, I'm gonna skip a little bit this. So it's going and sending the information of a specific location and a magnitude that you want to create for a specific earthquake. And it's using the model that is pre-defined in PyIncor. It's called Atkinson board. But again, there are many different tools nowadays. For example, you can check OpenQuake for creating different hazard analysis. Finally, you have now created the hazard, the earthquake, the data set of bridges and the mapping, and you can connect them together to run the simulation. Let's go back here. So you can create here the regional scale simulation. Here, what we're using is going with the data set and adding the different scenarios and creating one result per scenario. Each result of something happening with my connection. Let's go back. Okay, maybe now it's fine. Okay, now we're running the different scenarios, and you see here that every time that it is running one, it's saving a result here. A second year is going to appear. And if you open one of these CSV files, you're going to find that the globally unique identifier, that means one specific asset, now has the damage probability, or in this case, is the exceedance probability for exceedance of no damage, exceedance of damage, slide, or depending how you call them, or the probability of being in each damage state. So this input information was very easily obtained thanks to this interoperability. We didn't have to create the fragility functions. We leveraged data from a data depot in DesignSafe. So now we want to run our simulation of the network resilience. Before, we want you to check very quickly different ways of visualizing the data. For example, you can leverage volume to observe a way to interact and read the damage probabilities. This is very important when you are communicating your outcomes with decision makers, for example. Or with Plotly, the previous one was showing specific values separating the colors by damage state probability. In this case, it gives you a different way of observing. You can also export this as a JPG file. Now, if you want to publish this in a paper, you can also, for example, publish your network. And in this case, we have created a data set that pulls the data from the bridges and passes the damage probability to the links. So you can see now the links are colored because we're going to use that information to recognize if they are functional or not. So the network resilience analysis that I mentioned in the slides consists on using those damage probabilities, this one, and simulating possible damage states of each bridge. And for each network state, we're gonna start collecting or simulating times to recover, and then scheduling the recovering process, and then computing the network efficiency for each network state. So those steps are presented here. What we do is we need to create a network model using network X. From this point on, we are not using PyEncor. We are using our own codes that are in this Jupyter notebook. To create the network X, there are different ways of doing it. You could, for example, use the shapefiles that are already presented. To avoid making this code longer, I leverage data. Leverage data that was already existing in the PRJ 3939. For example, the information of the edges, information of the nodes, or the bridges. And with that, we created a model or a network. Usually you use the letter G. So this is our network in G. The set of scripts that are going to be used are this one. So I just want you to focus on two, sorry. First, we create the possible network states using Monte Carlo. It's just sampling the possible damage states of the bridges, 100, 10,000, the number of simulations that you want. And the most important function is this one, compute resilience trajectory. And I want you to see the structure of this function. It is a single function with a single input, one input list. But in this way, you could then below disaggregate the input list with the set of intermediate, sorry for this, with the set of intermediate input parameters that you need to populate all of the chained models. In this way, we're going to leverage the HPC. So now, what it's doing is taking every time, going and computing the bridge recovery time, obtaining the bridge times, then you see that is used as an input, and then you obtain the schedule of the months, then you use that for the next one. So you see it is a chain model inside. Why we did this? Because then we're going to call a parallel function where this is the main function and this is the input list. And we're gonna leverage that capability in DesignSafe. I'm gonna skip this, that you can then check in detail how we compute everything, but I'm going to give you an example. For example, I created 100 possible network states and took the first one. For the first one, I said to the model, I don't care about the bridge priority, so it's going to randomly assign the bridge priority to decide which bridge should repair first. I selected 10 crews and a time step of 3 months to check different times how the network recovers. And again, the only function that you have to pass is compute resilience trajectory. You see here is 1.64 seconds per simulation. That is a little bit expensive for a single simulation. And it gives you two outcomes, the time steps plus the network efficiency time already normalized. And this is the outcome. You see this figure going from, it's bounded between 0 and 1. Now, if we want to do this for multiple number of simulations, I already mentioned, you have to leverage that in a parallel process. The parallel function is very simple. You pass the function, in this case is the compute network resilience, and the list input is a list of lists, okay? So you leverage this function, and this is what you do. For example, let's run here in this Jupyter session 20, 40, and 60. If you run this, it's gonna create a list of lists, and it's gonna send that through the parallel. And in this Jupyter session, we are already running HPC. We're running in parallel with 10 workers. 10 workers that you can assign. If you don't know the number of workers, this function is gonna do it for you. If you know the maximum number of workers you want to use, you can pass it, or you can pass the percentage of the number of workers that you could use. For example, this function will count it for you, and it will assume a number that is suitable for your analysis. While this is running, it's going to be very fast. Before we go to the HPC, I want to show you here, we put 2 examples additional for communicating network resilience, because you want to publish, for example, this as a project for the data input. If you want to do that, you could, for example, present a time-dependent figure. In this case, it's going to be a simple one. It's going to be a GIF. And what we could do is we could take those intermediate outcomes, such as the scheduling of the bridges, and create a figure that presents in which state they are. So all of these steps are taking into account which time you're trying to plot the figure, and as well as these are creating the GIF. It's taking a little bit more. Let me see. Okay, it finished. So 43 seconds for 60 simulations. Let's go back. So this is the function now. Once it runs, now it can continue. This is the type of plot that you could create. This is static. But if you just copy and paste the same function and add probably 5 lines, just these 2 lines plus these 3 lines, you're gonna create a very nice way of representing your data. Again, you will check, and the previous cell is almost the same here, just 5 lines additional, and we could create a GIF that is gonna show at some point here. It's running. Okay, so what we're gonna do is just gonna update the time, and it is going to check the different damage states or the functional states of the bridges. And it's ready. If we open that, this is something that we're gonna see. We like this, and it was very similar to one that Dr. Payet mentioned or showed in her slides. You could also show that in your Jupyter notebook, so you call that. Let's say that until this point, we are leveraging PyIncor and data depot already existing data published. From here, we could publish this to the public, so everyone could use our Jupyter notebook. But let me finish now with a larger number of simulations. What you need to do that is to copy. In this case, we want to run our HPC. I already mentioned you start in this position, and you're gonna see my data and work. Let's take from my data, or let me go back because I want to mention something. I don't want to run again PyIncor. I don't want to again call everything. I want to simply pass the input data that I need to rerun this. So what we created here is, let me show you the simulation. This is the network recovery that we obtained with 20, 40, and 60. And for the parallel job, we don't need all of the previous steps. We just need the network that is saved as G, the damage states, and the information in the data. So using Pickle, I saved this data in a file called input package that is saved here as input package. And I can run just copying this to the HPC space. So I'm going to copy the Jupyter notebook and let me save this Jupyter notebook and the input package to your folder work. You go to Stampede 3 and you create a folder here where you copy, in this case, only these 2, right? But look that I have to jump to the next session because here is where we have the power. We are in my work, Stampede 3. So here I will open, and I want you to check one thing. Previously, I was working with the kernel environment 1, because in this one I had installed PyIncor. In this case, we have IPyKernel 3. We don't need PyIncor in this case. So I'm gonna just go directly to the location where we can continue. Everything is written here, so sorry if I am running, but it's for the matter of finishing on time. So what happens once we are in the parallel area? So the example needs you to run specifically some cells. We have added some instructions. They say copy the input package and the Jupyter Notebook in a new folder and run these two cells. The first one, so if you click here, it's sending us to the script. So let's run this script. So all of the instructions are here. And the second one is running the code for the parallel jobs. So once you run these two, now you can run the rest of simulations. The first thing that we're going to do is to compare with these 20, 40, and 60 simulations with the regular Jupyter session. What happens if we run this now with the multi-parallel or the HPC? Again, what we're trying to show you here is how you can pass from one side to the other. That's why I'm jumping from one side. I'm jumping from Incor, I'm jumping from the data depot, now from Jupyter to Jupyter HPC. You could see while the previous one spent 43 seconds in 60 simulations, here we're running in 1 second, the same 60. And here we're just using one node. But if you, for example, create here an API, you can set this to using more nodes. So you could, instead of using 64 workers, you could use 600 workers or 2000 workers, which means that instead of 20, 40, and 60, we could run 100,000 or 10,000. So depending on what you need, this could be an approach. Again, typically we rely on simulating or chaining different models. And here it's going to take some minutes, but we can check those results. For the 10,000, that was the largest is like 3 minutes. So now that we don't have time, I have another one. I have these results. And this is how it's going to be looked. So I'm showing you here, instead of 2 seconds for 60, we have 4 seconds for 100, 19 seconds for 1,000, and 3 minutes for 10,000. And this is the result. So depending on how many simulations do you need for your outcome to be reliable, 60 may not be enough. So you need HPC capabilities to expand or get more accurate results, or at least have the better statistics of your outcomes. Finally, with this command, this automatically saves your Jupyter notebook. So if, for example, you could close everything and leave your computer, and it doesn't matter if the session finishes, this is gonna save for you the Jupyter as is. With that, I would like to finish my presentation, and sorry for running. I hope it has been a good explanation. Then we are happy to receive questions. Also, if you have questions, you can send us through email.
Thanks, Raul. Yeah, I've been trying to answer any questions that came up in the Q&A in the chat. We're happy to answer more, so we can stick around for a few minutes and see if any others show up. I think in the meantime, as you're considering those questions, just some takeaways that I hope you'll leave with. One, we've seen examples today of leveraging published data on DesignSafe to enable a risk and resilience computation, interacting with Incor to utilize some of the data and models that are already there, but then also seeing how you can combine that with your own codes and scripts and leverage some of the HPC resources on DesignSafe. And as Raul mentioned, we will be sure to publish and share that Jupyter notebook with you. Feel free to also cite that notebook and leverage some of the text from it, some of the code, and build off of it for your own examples as well.
All right. I have a couple closing remarks here. Oh, there is a question from Bijan. It says, would you explain more about the validation of the results and how we can trust the results?
Maybe I'll jump in here real quick. Since we're short on time, today certainly we did not show any verification validation as a part of that code and script. And so I think that opens up a whole separate can of worms about looking at verification validation at each individual, kind of component of that model. You'd like to do that with the fragilities that we pulled, and you can go back to some of the documentation from NCORE on those original models. So that's, I think, one level of verification validation is the models themselves in terms of trusting the predictive outcomes. And that's really challenging in this field. But I think there's a different level that you might also be hinting at, which is with respect to just the model coupling. And that is certainly something that I think you could go back and learn in terms of looking at potential reproducibility of some of the outcomes. And that's one thing we're trying to facilitate, encourage through sharing directly of these codes and scripts and input data. But I'll pass it back to Charlie for now, and we can follow up with you, Bijan, on some of the submodels.
All right. Did get a couple comments on where we can find these webinars once the recordings was done. So the recording from Zoom will come in. Our team will then curate that, and then we'll publish it to DesignSafe. And you can see that here. If you go to that URL, or if you click on the learning and training archive on the main DesignSafe site, this will take you to this site here from the Learning Center. And all of our webinars are posted here, and they're also posted and shared on our YouTube channel. So feel free to check those out there. Doesn't seem to be any other questions yet. Whoops, there we go. Once again, there's that QR code. Please scan that and please give us your feedback. We would love to hear it. We would love to present more material like this if this was and where your interest lay. And of course, thank you so much to Jamie Padgett and Raul. It's awesome to see how DesignSafe has kind of flourished and has gotten into other areas besides, the core functionality that started, 5 years ago, 10 years ago. So I really appreciate y'all's commitment and really appreciate the community that you're building with this. So thanks so much, y'all. If there are any other questions, feel free to ask us now in the Q&A session, or you can always find us on Slack and ask us questions there. If you have anything else that you would like to discuss or talk to, please feel free to contact us. You can email us at training@DesignSafe-CI.org, and we'll be able to answer those questions for you. All right. Thanks so much, everybody. Thanks so much for joining us. Thanks so much again, Jamie. Thanks so much again, Raul. I really appreciate catching up with you all and seeing how your research is going. And once again, Raul, congratulations. So, all right.
Thanks,
Thanks, everyone.
Thank you so much.
Charlie.
Yep. See you all next
Bye.
time.